And good morning YouTube. Another bright and sunny day here in Cheshire in the UK. Welcome to Simply Diagnostics. Before we start, don't forget to hit the subscribe button and hit the bell for the notifications. You can also follow me on Twitter @PicoFlu, on my Facebook page Simply Diagnostics Northwich. Comments and criticisms always welcome. If you've got something to say, put it down in the comment box below and we'll get a conversation started. Thanks for watching. Today we're going to be taking a quick look at reading wiring diagrams and specifically interpreting Vauxhall Vectra central locking and window diagrams as requested by a subscriber. So stick with me, it's only going to be a screen capture video. I hope you enjoy it. So as you saw there, that was an old version of Test2Web that I had years and years ago. But we're going to be using today, we're going to be using the latest wiring diagrams from AllData. It's similar to Autodata, but it's brilliant for manufacturers' wiring diagrams, all the up-to-date information, the latest wiring diagrams to VIN. So what we've got here, basically, we've got a layout of the passenger door central locking. We've got up here at the top left, we've got passenger door module. For vehicles that are fitted with anti-theft, the BCM, the body module is also part of that, but for non-anti-theft vehicles or vehicles that haven't got an alarm, it's all done through the passenger door module. We've got the central locking motor down here for the passenger side, the door switch here, and then we've got the switch pack on the actual door. So basically anything I've got highlighted in green are a grounds or a low reference, and basically the other wires, you've got here on this leg, you've got illumination for the switch pack, central locking commands here, window up command here, the door switch wires here, up control, unlock control, sorry, lock control and deadlock control. And what you'll notice straight away, if we're looking at the central door locking motor itself, there's no path to ground from this motor. So what will happen is the lock and the unlock wires will change state on depending what you're doing. So let's say, for example, you're going to unlock, then the black yellow here will be live and the black red will be ground. And then if you're going to lock the vehicle, the black red would be live and the black yellow would be ground, and that's done through the passenger door module. So if we look at an alternative wiring diagram, this one's from Haynes Pro for the same vehicle. You can see, if I just zoom out, you can see a generic wiring diagram either makes it more clear, either gives you a bigger picture, or less clear. Myself, I've always preferred the manufacturing wiring diagrams, but I must admit I do like Autodata, but for some strange reason Autodata don't list central locking and windows on their wiring diagrams for this vehicle. It's not like there's not many of them about, so yeah, I don't know what that was all about. So looking at the Haynes Pro diagram, basically we've got the passenger door module up here. A664 is the passenger door module. S45 is the passenger door switch pack. M617 is the passenger door central locking motor and door position switch. Then on the left hand side here we've got the driver's master switch for windows and things like that. Down at the bottom we've got the driver's door module A7692. S70 is the driver's central locking motors, and then the grounds are listed here. So if we just go back up to the passenger where we were, you can see there are no wires whatsoever coming from any of the any of the other switches on the vehicle or doors on the vehicle, everything is coming into the passenger door module on a LIN, and the only direct connection to the passenger door module we have is from the motor or from the passenger that's the passenger door module, and the only direct connections we've got coming from that is from the passenger switch pack and the passenger central locking motor itself. So again, we're looking for common grounds. If you just follow the cursor, I don't know, can you see it? If you just follow the cursor, we're looking for a path to ground or a path to power. The only common thing we can see right the way through is this row here, which is exactly the same as I highlighted in green on the old data diagram. So that's going to be a low reference or a ground, and everything else coming into it is going to be live. So any outputs or anything like that, we're going to be looking for a voltage change basically, and that voltage change will be reflected back into the passenger door module, and will signal a driver request. Looking at the motors over here, you can see exactly the same again. We've got no clear path to ground, no clear path to power, and all we can deduce from that is that for whatever command is given, the polarity of the wires will switch. So that's the Haynes Pro version of the wiring diagram, and you can see it's also a two-parter. So if I go on to the part 2, this then gives us the rear door locks, the fuel filler flap, and the hatchback release. So Y254 on this will be the boot tailgate lock. A42, obviously this is the door position switch, so A42 will control the interior light. And you can see from both motors, well, from 3 motors, 762, what's 762, fuel filler flap. So you can see the motors are all connected to A9489, which is the GEM or the body module, BCM, whatever you want to call it. Same system, 3 wires going to the motors. One will be unlock, one will be lock, and one will be deadlock. The door switch themselves, which will give you a path to ground, which is shown clearly here, a path to ground through the door position switch, which will tell the module, the relevant module, that the door's open or closed. Same on this motor pack here. Yeah, so really that's about it. The only thing you can say is the fuel filler flap, there's only motor controls, there's no state monitor on that. So what you can gather from that straight away is that the vehicle wouldn't have sliding doors, which obviously a Vectra wouldn't. So yeah, you know, it's interesting to see how different wiring diagrams portray the same systems. I do like Autodata because it tends to give you everything in one big picture. The failing there is that, like I say, for a 2006 Vectra, it doesn't have central locking or window wiring diagrams. So then I'm forced to use AllData, Haynes, or the manufacturer's portal for stuff like that. We have a quick look at the wiring for the door modules themselves. On the Vectra, there's very few wires that go between modules. Normally it's done on a LIN network, which is a single wire network. I'll pull the Pico capture up now and we'll have a look at a typical LIN signal. But you can see basically so A1X97 is what we call the rear electronic module, and that's going to the driver's door module, the passenger door module, then the left and the right door modules, and it's all done on a LIN signal. So we'll get the Pico software up now and we'll show you what I mean. So basically what we're looking at here, this is from the Pico Automotive help files. Your typical limb bus is a single wire, battery voltage, digital square wave signal. Basically it's a data signal, and it says here at the bottom, local interconnect network or LIN bus communication is becoming more common on modern CAN bus equipped vehicles. It's essentially a low speed single wire serial data bus. It's a sub bus of the faster, more complex CAN used to control low speed non-safety critical housekeeping functions on the vehicle, especially windows, mirrors, locks, HVAC units and electric seats. The LIN bus is proving popular because of its low cost and also because it reduced the bus load of the supervising CAN network. Look at the picoscope screenshot. What we can see is we've got a time-based 1 millisecond per division and 500,000 samples per interval. Very, very simple. You've got a signal. The baseline basically is battery voltage, and it's an on-off signal. You'll notice it's not going all the way to ground. It's normally starts from about 1 volt, and that way then it can detect if it's got a short to ground. So basically that's the overview of how a LIN bus works. It's a single wire communication network for module to module communication on comfort and convenience systems on a vehicle. Right, so going back to our wiring diagram, the part we're interested in really is the passenger door module, the switch, the motor and the door switch. To be honest, I've never really had much problem diagnosing faults like this. It's normally a quick look at a wiring diagram to have a look at the basic setup, the basic states that things should be in, and then off we go with my test light or my multimeter. Actually sitting here trying to dissect it for the camera or for the video is quite difficult. So basically any request that we have for any change of state in either the windows or the motors, the door locking motors, has to go through a door module. So the driver request will come through any of the door switches to the relevant door module, and then from that door module, then that will then actuate the actuator. It'll move the actuator, whether it's to lock or unlock the doors, whether it's to send the windows up and down. So here's the window motor, and you can see the window control is actually controlled directly by the modules. They're not controlled by the switches. So the switch will send a request to the module, and then the module will actually do the work. Will actually will actually actuate the motors. So we go back to the central locking. Again, we're looking at the passenger side front here. One of the most critical circuits with central locking are the actual door switches, highlighted here down at the bottom, Y13P. You wouldn't normally find power going to these door switches. What it will be, it'll have a low reference or a ground going to one side of the switch and back to a module, and then the other side will be a dead wire waiting for a response. There might be a slight bias voltage on it, but not all cars have that, and basically all it's waiting for is if the door closes, then there's a path to ground between here. You can see terminal 42 and 34. So when that door switch is closed, basically there's just a path to ground straight through those wires there, and that will tell it that the door is closed. If it sees an open circuit on there, then it assumes the door is open. Well, obviously with door looms, they fracture and they break. That's one of the most common faults you'll ever come across on any central locking circuit. Will normally be the door switch. The vehicle, the relevant module, won't know whether the door's open or closed, so it won't allow the central locking to work. This also comes into play on vehicles with sliding doors, such as the Kangoo vans and that have got a filler cap and a sliding door on the same side as the filler cap. If it doesn't know that the filler cap's open or closed, it won't allow the door to open or close. So that's something to bear in mind. So quickly going through this, all we've got basically, we've got voltage coming down to these, coming down to the wires. This isn't a complete diagram. This is for the central lock-in, so the window down terminal is missing on this drawing. But basically, we've got battery voltage coming from the passenger door module down to the switch. We operate the switch. It will then obviously go through the resistors and back to ground. The passenger door module will detect that change in voltage and will actuate the motor accordingly. And that's about all it is. Like I say, the most critical circuit on any central locking system are the door switches, because if it doesn't know if the door's open or closed, then it won't actuate any of the motors. I normally just have a quick look at the wiring diagram, run through what I've got with me test light, and all I'm really looking for is a change of state on any given wire, and that's about it really for central door locking. And if we look at the rear central locking, what you'll see is that the rear doors don't have their own separate modules. The rear doors will work off the body module, and the information for the system gets to the body module via a LIN network. You can see the two motors, the left and the right motors for the central locking, are configured in exactly the same way as the fronts. So we'll have an unlock, a lock, and a deadlock wire on each of the motors. I'll just highlight that. So we've got unlock, lock, deadlock on each of the motors. Then we've got our door switch here going to ground, and all this wire is doing, it's looking for basically a change. It's looking for a path to ground on this wire. Then the body module at the top knows that the door is closed. Very, 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 I can't say very enough times, common fault with these is basically the door switch wiring breaks off in the flexes. That's normally the first thing I do with any central locking fault is just quickly have a open the doors, have a look, see if the flexes are butchered, if they feel as though they've had previous repairs. Shove the scan tool on. Well, before that, close all the doors, turn the ignition on and see if I've got a door open warning sign or a door open chime or something like that. If there's no visual indication, then I'll put a scan tool on it and see if I can see door states in live data. The same with the rear, with the tailgate. If we look over here at M1Y29, really exactly the same sort of setup, only this one will have a separate button. It doesn't quite operate in the same manner. So I hope you found this video interesting. It is only a short video. Hopefully what I'll do is I'll do a central locking, an actual video on the vehicle where I'm running through the circuits and what to be expected. But to be honest, there's thousands of those videos on YouTube, and I don't think you really need to see another demonstration of that. It's more just interpreting wiring diagrams. So again, if we go back to the passenger door, all I'm looking for, just change my colour so you can see it. All I'm looking for, I'm looking very, very closely at the wires coming in and out of the motor. Is there a path to ground? If not, if both wires go back to the module, then you'll normally find that those wires will switch polarity depending on the command that's being given. They'll alter between battery positive and battery negative. So that's that. The first thing is you always look for a path to ground or a path to power, so either something leading to a fuse or something leading to a ground point. I'm in the fortunate position that I've got an old copy of TIS. and I'm able just to pick the low references out, but you can actually see it. If I erase this ink, I'll try and get rid of it. If we actually look at this, there's no way that coming from pin 36 of the passenger door module on a brown white wire is going to be live. It's just not going to happen. And then obviously you get to the diode here, the power kettle, nothing can go past that anyway. So it's got to be this has got to be a low reference or a ground. So therefore everything that's coming down these wires would have to be the opposite, would have to be power. And that's all there is to it. There's nothing overly complicated. You're just looking, like I say, you look for any external paths to ground or paths to power. If both wires go back to the module, you can almost guarantee that on a central locking or a window circuit that those wires will change state depending on the command being given. Hopefully you enjoyed this video. If you did, don't forget to give us a thumbs up. If you didn't enjoy it, give us a thumbs down and please comment why. I can only improve if you give me some critical feedback. If you'd like to subscribe, that'd be awesome. And share the channel. There's also ways you can support the channel now. We've got Patreon going and Buy Me a Coffee. And there's also a PayPal link down at the bottom if you feel like supporting the channel. All that will go towards helping the channel grow, better equipment and stuff like that. So whatever you do, thanks very much for watching. Thank you for the support, and I look forward to the next video. Thanks for watching.